The ground beneath you begins to move. You're standing on what you thought was solid earth, a dam under construction, millions of tons of soil and rock, and then it is not solid anymore. It is liquid, flowing. You try to run, but the earth moves faster. It pulls you down, buries you, and you are never seen again. September 22nd, 1938, Fort Peck Dam, Montana. The Missouri River, one of the largest earth dams ever attempted in America. A New Deal megaproject. Thousands of workers, years of effort, and on this day, a section of the dam fails. Over 1 million cubic yards of earth slide into the river in seconds. 8 workers are swallowed, buried alive. Their bodies are never recovered. They remain entombed inside the dam to this day. But here is what makes this disaster even more disturbing. Engineers knew the soil was unstable. Warnings were given. Tests showed the fill material was behaving strangely, but the project was too important to stop. The Great Depression was crushing America. Fort Peck Dam was a symbol of hope, jobs, progress, proof that American engineering could conquer nature. So the work continued, and 8 men paid with their lives. The slide created waves 40 feet high. It sent shock waves through the engineering community. Soil mechanics in the 1930s was still a developing science. Engineers thought they understood how earth dams worked. Fort Peck proved they did not. The dam was an experiment, a gamble, and when the soil turned to liquid under pressure, the gamble failed. This is the story of the Fort Peck Dam landslide, the 8 men who were buried and never found, the New Deal project that nearly collapsed, and the questions about soil and safety that were never fully answered. The Fort Peck Dam project began in 1933. President Franklin D. Roosevelt's New Deal was in full swing. The country was in economic collapse. Unemployment was catastrophic. The government launched massive public works projects to create jobs and rebuild infrastructure. Dams were a priority. They provided flood control, irrigation, hydroelectric power, and, most importantly, they employed thousands. Fort Peck was one of the most ambitious. The dam would be built on the Missouri River in northeastern Montana, a remote location, harsh winters, minimal existing infrastructure. But the river was perfect for a large reservoir. The dam would create a lake over 130 miles long. It would store water for irrigation across the Great Plains. It would generate electricity, and it would employ up to 10,000 workers at its peak. The U.S. Army Corps of Engineers was put in charge. Construction began in 1933. The design was an earth-fill dam. Not concrete, not steel, just earth. Millions of tons of soil and rock hauled from nearby sites and piled into a massive embankment across the river. The dam would be over 250 feet high, nearly 4 miles long, one of the largest earth structures ever built. Earth-filled dams were not new. They had been used for centuries, but Fort Peck was on a scale never attempted before, and the science of soil mechanics was still evolving. Engineers in the 1930s did not fully understand how soil behaves under pressure, how water affects stability, how different types of earth compact and settle. Fort Peck would be a learning experience, sometimes a deadly one. The construction process was brutal. Workers operated massive dredges that sucked material from the riverbed and pumped it onto the dam. Bulldozers spread the fill. Compaction equipment pressed it down, layer after layer. The dam grew slowly, steadily, but problems emerged early. The fill material was not uniform. Some of it was clay, some of it was silt, some of it was sand. When water mixed with certain types of fill, it created a slurry, almost liquid. Engineers called it hydraulic fill.
It was unstable, dangerous, but they used it anyway. By 1936, the dam was over 100 feet high. Workers and engineers noticed strange behavior. The upstream face of the dam would sometimes bulge, small slides occurred, cracks appeared. Engineers monitored the situation, they took measurements, they installed instruments to track movement. Some experts warned that the dam was at risk of a major failure. But stopping construction was not an option. Too much money invested, too many jobs at stake. The work continued. In 1937, additional concerns were raised. Poor water pressure inside the dam was higher than expected. When soil is saturated with water, the pressure between soil particles increases. If the pressure gets too high, the soil loses strength. It can behave like a liquid. This phenomenon was poorly understood at the time. Engineers at Fort Peck were learning on the job, and the lessons would come at a terrible cost.
Building Fort Peck Dam required an enormous workforce. At peak construction, over 10,000 people worked on site. Many lived in temporary towns built near the dam. Boom towns sprang up overnight: Wheeler, New Deal, Park Grove. These were rough communities. Makeshift housing, saloons, brothels. Workers came from all over the country, men desperate for jobs during the Depression. They worked long hours in harsh conditions. Winters were brutal. Temperatures dropped below zero. Summers were scorching. The Missouri River flooded regularly, but the work never stopped. The construction method was innovative but risky. Massive floating dredges operated in the river. They sucked up material from the riverbed, sand, silt, clay, and pumped it through pipelines onto the dam. The slurry was deposited in layers. Water drained away. The material settled. Bulldozers spread it. Compaction equipment rolled over it. Slowly, the embankment grew. But the hydraulic fill method had flaws. The material did not compact evenly. Pockets of water-saturated soil remained inside the dam, and because the fill was placed so quickly, there was little time for it to settle and consolidate. Engineers knew this was a problem, but they believed the dam design accounted for it. They were wrong. By September 1938, the dam was nearly 200 feet high. Work was progressing on the upstream face. A crew of workers was placing additional fill material. Trucks hauled earth to the edge. Bulldozers pushed it into place. It was routine work, until it was not. On the morning of September 22nd, workers noticed unusual movement. The upstream slope was shifting. Cracks appeared. Supervisors were alerted. Some workers were told to move back. But not everyone got the warning. And then the slide began. September 22nd, 1938. Mid-morning. The Fort Peck Dam begins to move. Not slowly, not gradually, all at once. Over 1 million cubic yards of earth and rock slide into the Missouri River. The movement is catastrophic. Soil that was thought to be solid behaves like liquid. It flows, it surges, it buries everything in its path. 8 workers are on the upstream face when the slide occurs. They're operating equipment, placing fill, doing their jobs. They see the ground moving. Some try to run, but there is nowhere to go. The earth is collapsing beneath them, around them. It pulls them down, engulfs them. In seconds, they are gone, buried under a mountain of mud and rock. The slide does not stop at the dam. The mass of earth plunges into the Missouri River. It displaces massive amounts of water. Waves 40 feet high surge upstream and downstream.
Dredges and equipment in the river are swamped. Some are capsized. Workers on boats scramble to safety. The river churns with debris and mud. The entire area is in chaos. Rescue efforts begin immediately. Crews search the slide area. They dig. They probe. They hope to find survivors. But the slide is too massive, too unstable. Digging in one area causes more movement in another. The search is dangerous, and it is futile. The 8 workers are buried too deep, under too much earth. They are never found. The names of the lost workers are recorded. Wilbert G. Igoe, Joseph P. McElroy, Bert Sheldon, Tom Mullen, John C. Walling, Mike Sheehan, Nick Konachek, Clyde Naden. 8 men. Fathers, brothers, sons. They came to Montana for work, for a paycheck, for a chance during the Depression, and they died doing a job that should have been safe. Investigations began immediately. The U.S. Army Corps of Engineers formed a board of inquiry. They examined the slide area. They reviewed construction records. They interviewed engineers and workers. And they tried to understand what went wrong. The conclusion was disturbing. The slide was caused by liquefaction. The hydraulic fill material inside the dam had become saturated with water. Poor water pressure built up. The soil lost strength. And when the pressure exceeded a critical threshold, the soil behaved like liquid. It flowed. The upstream face could not hold. It collapsed.
But liquefaction was not well understood in 1938. Soil mechanics as a science was in its infancy. Engineers at Fort Peck were operating on incomplete knowledge. They knew the fill was unstable. They had seen small slides. They had measured high pore pressure, but they did not fully grasp the danger, or they chose to ignore it. Some engineers had warned that a major slide was possible. They recommended slowing construction, allowing the fill to settle, reducing the rate of material placement, but project managers were under pressure to meet deadlines, to keep workers employed, to show progress. The warnings were noted, but they were not heeded. After the slide, work on the dam stopped. Engineers reassessed the design. They conducted new tests. They studied soil samples. They consulted with experts from around the country. The dam had to be made safe, but it also had to be completed. Too much had been invested, politically, economically, symbolically. The solution was to flatten the upstream slope, make it less steep, less prone to sliding. Additional drainage systems were installed to reduce poor water pressure. Construction methods were changed. Material was placed more slowly. Compaction was improved. The dam was redesigned based on hard lessons paid for with 8 lives. Work resumed in 1939, but the shadow of the slide lingered. Workers were nervous. Engineers were cautious. Everyone knew that 8 men were still buried inside the dam, entombed in the structure they had helped build. Their bodies would never be recovered. They would remain there. Part of the dam. Part of history.
Fort Peck Dam was completed in 1940, 7 years after construction began. Thousands of workers, millions of dollars, and 8 lives lost. The dam stood 250 feet high, nearly 4 miles long. It held back a reservoir over 130 miles long. Fort Peck Lake, one of the largest man-made lakes in the United States. The dam worked. It provided flood control, it generated hydroelectric power, it supplied water for irrigation. It was an engineering success, but the cost was high. The slide of 1938 nearly destroyed the project. It exposed flaws in engineering knowledge. It proved that even massive government projects with the best engineers could fail, and it left 8 families without answers, without closure, without bodies to bury. A memorial was eventually erected, a simple plaque. It lists the names of the 8 workers lost in the slide. It stands near the dam, a quiet acknowledgement of the price paid. Visitors to Fort Peck can see the dam, walk across it, admire its scale, but few know the story of the slide, or the men buried inside. The completion of Fort Peck Dam was celebrated. President Roosevelt attended the dedication. He praised the workers, the engineers, the vision of the New Deal. He spoke of progress and hope, but he did not mention the slide or the 8 lost lives. The focus was on success, on what had been achieved, not on what had been lost. The dam's completion also marked a turning point in American engineering. The lessons learned at Fort Peck changed how earth dams were designed and built. Soil mechanics became a more rigorous science. Engineers developed better methods for testing soil stability, for managing pore water pressure, for predicting and preventing slides. Fort Peck was a case study, a warning, a reminder that nature does not always behave as expected. The Fort Peck Dam landslide remains one of the most significant failures in the history of earth dam construction. 8 workers lost their lives. 1 million cubic yards of earth slid into the Missouri River. The project nearly collapsed. But the lessons learned reshaped engineering practice. Before Fort Peck, soil mechanics was an emerging field. Engineers relied on experience and intuition as much as science. Testing was limited. Understanding of pore water pressure, liquefaction, and soil behavior under load was incomplete. Fort Peck forced the profession to advance. After the slide, the Corps of Engineers invested heavily in soil research. Universities developed soil mechanics programs. Testing standards were created. Engineers learned to predict and prevent failures. The concept of liquefaction became better understood. When water-saturated soil is subjected to stress, pore water pressure can increase to the point where the soil loses cohesion. It behaves like a liquid. This phenomenon caused the Fort Peck slide. It has caused failures in other dams, in foundations, in embankments. Understanding and controlling it became a priority. Fort Peck also highlighted the dangers of rushing construction. The project was under political and economic pressure. Jobs needed to be created. Progress needed to be visible. Warnings were ignored. Safety concerns were minimized. The result was a disaster. Modern engineering practice emphasizes safety over speed, peer review, independent analysis, transparency. Fort Peck taught that lesson the hard way. The 8 workers who died are not forgotten. Their names are on a memorial. Their story is part of the dam's history, but they remain buried inside. Their bodies were never recovered. Families never had funerals, never had closure. The dam stands as both monument and tomb.
Fort Peck Lake is now a recreation destination. Boating, fishing, camping. Thousands visit every year. The dam itself is a landmark, a testament to New Deal ambition. But beneath the surface, the slide scar remains. Geologists can still see where the upstream face failed, where 1 million cubic yards of earth moved, where 8 men were buried. The dam has performed well since completion. No major failures, no further slides. The redesign worked, but the memory of 1938 lingers. Engineers who work on earth dams study Fort Peck. They learn about liquefaction, about pore pressure, about the dangers of hydraulic fill. The slide is a case study, a cautionary tale, a reminder that engineering is not just about building. It is about understanding, about respecting the limits of knowledge, about learning from failure. Fort Peck also stands as a symbol of the New Deal, of government intervention during crisis, of massive public works projects that reshaped America. The dam provided jobs when jobs were scarce. It brought electricity to rural areas. It controlled floods that had devastated communities. It was part of a larger vision, a belief that infrastructure could lift a nation out of a depression. But that vision had a cost. 8 men, buried in earth, never found. Their sacrifice was not in vain. The dam stands. The lessons were learned, but the price was real, and it is worth remembering.
The Fort Peck Dam landslide of 1938 buried 8 workers under 1 million cubic yards of earth. Their bodies were never recovered. They remain entombed inside the dam to this day. The disaster nearly destroyed one of the New Deal's most ambitious projects. It exposed gaps in soil mechanics science. It proved that even the best engineers can be wrong, and it changed how America builds earth dams forever. The slide was caused by liquefaction. Water-saturated soil lost strength and behaved like liquid. Engineers in the 1930s did not fully understand this phenomenon. Fort Peck forced them to learn. The dam was completed. It has served its purpose for over 80 years, but the 8 lost workers are part of its foundation, literally. They are still there, under the earth, under the water, part of the Missouri River, part of history. If you want to uncover more stories of American infrastructure hiding dark secrets, subscribe to Hidden America. Next time, we will explore the Citicorp Center crisis in New York City, where an engineering student discovered a fatal flaw in a 59-story skyscraper 1 year after it opened. Emergency repairs were done secretly at night while a hurricane approached, and the public knew nothing for nearly 20 years. Subscribe now for more hidden infrastructure stories. And remember, Fort Peck Dam taught America that progress has a price. 8 workers paid it, and their names are the only memorial they ever received.